In this video I'm just going to talk about the introduction to what an arithmetic series is. Sometimes arithmetic series, by the way, are called arithmetic progressions, which for short I would call APs. Arithmetic progressions. It means the same thing as an arithmetic series. And basically all a series is a sequence of numbers that have all been added together. Okay, that's what a series is. So for an example, e.g. then, here is a very typical example of a sequence of numbers: 1, 3, 5, 7, 9, and so on. And if you add them all together, that sequence of numbers becomes what we call a series. Now, for an arithmetic series, this is an arithmetic series, each successive number in the sequence, which is being added together, have what we call a common difference. In other words, the sequence of numbers are going up by the same amount each time. And in this particular one, the common difference between each successive term is common difference, which we indicate with the letter D, and in this case the common difference would be 2, so little d would be 2. This here therefore is an arithmetic series, okay, with a common difference of 2, and the first term, which we in maths call little a, would be 1. Okay, so this is an arithmetic series, first term a equals 1, common difference 2. Now as it stands, this is what we call in maths a finite arithmetic series. Finite because there's only 1, 2, 3, 4, 5 terms in this series. So this is a finite series of 5 terms. Okay, that's a finite series of 5 terms. So if I call that number 1, number 2, if I had something like 10 plus 13 plus 16 plus 19 plus 22 plus 25. Okay, looking at that, that is a sequence of numbers being added together, and each successive number in the sequence is bigger by 3. You're adding 3 each time to get each successive number in the sequence. So, because they're being added together, what we've got here, well, it's a finite AP, arithmetic progression or arithmetic series. This has got a first term little a of 10, that's the first term, 10, and it's got a common difference d, which is 3. And it's got 1, 2, 3, 4, 5, 6 different terms in this series, so it's a finite AP of 6 terms, with a first term 10 and a common difference of 3. Okay, so let's have a look at number 3. This one here, I've got 15 plus 22 plus 29. Okay, this one here is a finite arithmetic progression or arithmetic series. It has got a first term of 15. It's got a common difference, well, you're adding 7 each time, of 7, and it's a finite AP of just 3 terms, like so. Okay, so that's not very difficult. So that's a basic introduction as to what an arithmetic series is. Now, when you've got a finite number of terms, you'll always be able to actually work out what the sum of these terms are going to be. So for example, in this particular one, the sum of 3 terms, if I was to add them up, 15 and 22 is 37, 57, 66. So the sum of those terms would be 66. So for finite APs, arithmetic series, I can actually work out what the total is if I wanted to. And the sum of three terms in maths we could actually write down as S3, which is equal to 66. S3 stands for the sum of three terms. So S3 in that case is 66. I could work out the sum of 1, 2, 3, 4, 5. I could work out the sum of those 6 terms if I wanted to, or the sum of those 5 terms if I wanted to, just by adding them up. Now in some situations, the series that we're talking about get rid of all of them. Number 4, for example, might be something like this. 18 plus 28 plus 38 plus 48 plus 58, and it just goes on forevermore, dot, 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 dot. Well, in that case, we have got a sequence of numbers being added together, and they differ in size by 10 each time, so you're adding 10 to go from one term to the next term. So we do have an arithmetic series, but because it goes on forevermore, dot, 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 it's known as an infinite arithmetic series, or AP, arithmetic progression. The first term, A, would be 18. The common difference would be, well, in this case they're going up in tens, so the common difference would be 10. And because it's an infinite AP, arithmetic series, you can't actually define how many terms it's got. And as well as that, it would be impossible to work out what the sum of those terms add up to. All you could say is that the sum of the terms tends to infinity. As the more numbers you add up, the closer and closer it's going to get to become an infinite sized number. So that's an example of an infinite arithmetic progression. Okay, if I have a look at number 5, you might have one like this. You might have 32 plus 28 plus 24 plus 20 plus dot 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 dot, like so. In this case, you've got an arithmetic series, and because it goes dot 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 dot, it's an infinite arithmetic progression or arithmetic series. This time the first term is equal to 32, and as you'll see, this time each successive term is going down by 4, so the common difference is actually -4 in this particular instance. So you've got a common difference of -4, and once again you aren't able to write down this is an infinite AP of so many terms because it goes dot 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 dot, so you can't write down it's got 20 terms or whatever. Infinite AP, infinite number of terms, and obviously the sum to the infinite number of terms would give rise to an answer which tends to, well, because it would be going down smaller and smaller, sooner or later it would turn negative and go on ever decreasing in negativity. So the sum to infinity would actually tend to minus infinity for this particular question. So the sum would tend to minus infinity for you to add up those answers. So this is a basic introduction to what arithmetic series are. They're just sequences of numbers which have a common difference. Can be positive like that, positive 10, or negative like that, -4, and they are just simply added together. Okay, so there's nothing mysterious about them at all. They're very straightforward. I'll do one more with a slightly more awkward situation perhaps. You might have something like this. This is 3 plus 3 1/4 plus 3 1/2 plus 3 3/4 plus 4 plus 4 1/4. Okay, looking at that, I can see that that is an arithmetic series. It's a sequence of numbers, and they are being added together, and they are rising each time by 1/4. So I have got a finite arithmetic series, or AP, of 1, 2, 3, 4, 5, 6 terms this time. It's finite. 6 terms. Okay. I know that the first term, which we refer to as little a in this work, is 3. And I also know that the common difference, well, it's going up by a quarter each successive term. So the common difference is a quarter. And also, if I wanted to, I could work out what the sum of those 6 terms is. I'd have to add them up, obviously, but I could write down that S6 equals and write down the actual value. One final point before I finish this short video on the introduction to arithmetic series. One final point is that on occasions I might want to refer to, for example, the third term here being 38. Okay? Well, if you want to refer to something like the third term of a series, such as an arithmetic series, then you are entitled just to write down in maths T3, which stands for the third term. So in this particular instance, T3 is equal to 38. Okay, if I wanted to write down the fourth term, I put T4 equals 48, T5 equals 58. Slight exception to this, if you want to talk about the first term, you could write down T1 is equal to 18. Sorry, T1 is equal to 18. But normally, when we're referring to the first term, we give it the special letter little a. So, special case, first term we call little a. But apart from that, we'd use T2 equals 28, T3 equals 38, T4 equals 48, T5 equals 58, and so on. So in this one here, for example, yes, A, the first term, we don't call it T1, we say little a equals 3, but I could write down, I don't know if I wanted to, that T2, the second term, is 3 1/4. That would be a true statement to write down for this particular series. Okay, there's a basic introduction to arithmetic series or arithmetic progressions. In future and subsequent videos, I'll take you through some of the more complex ideas behind arithmetic series and introduce to you the idea of a formula that we can use to do some calculations.